Login accepted.
Okay, hi everyone. I hope you can hear me okay. I think you can now. My name is Alina, and I'm here to talk with you about GraalVM and all the things you can do with it for Java applications. Last time I was here, Devoxx Poland was 2 years ago. We have done a lot of work since then, and I'm here to show you what we've been up to those past 2 years. Now with that, if that's okay with you, I'm going to sit down because I'll be doing a lot of typing, but also I will be just a bit more comfortable. So let's go. And a quick intro. This is my name, and this is my handle on all kinds of social media. If you want to follow up, ask a question, ask me for demos, etc. And as I said, I work as developer advocate at Oracle, and more specifically at Oracle Labs. And Oracle Labs is this very cool unit at Oracle where we're doing a lot of R&D, developing new projects. It started back at the Sun Microsystems times, and we are still doing R&D at Oracle Labs. And I love open source and communities. That's why I like coming to places like this, where I get to talk to people in person. And I love both programming and natural languages. I have this interesting skill in Polish, where I cannot really speak it, but I understand it quite well. So if you want to test my Polish, you can talk to me during the breaks, and we can see how well I can do. And the last random fact about me is I'm a both cat and dog person. I own a cat, but if you're a dog person, don't come after me. I love dogs as well. Now with that, let's talk about GraalVM, and let's start with a quick definition. So one important thing to keep in mind about GraalVM is that it is a JDK, and it can do pretty much everything that all other JDKs can do, but what takes it apart from other JDKs is that it has this native image capability where it can take your Java applications and compile them fully ahead of time into native executables. Then you can just then deploy to a machine that doesn't have a JVM, and they will be fully functional, fully working on its own. And the reason why I'm emphasizing that GraalVM is a JDK is because there are many things that you can do with GraalVM. So there is this native image compilation, and there's also this polyglot capability where you can run other languages on GraalVM as a JVM, such as JavaScript, Python, you name it. So often people forget that it's also a normal JDK, but it is. We just add things on top of Oracle JDK or OpenJDK. So with GraalVM, you get to make this choice where you can run your applications either on GraalVM as a JDK, and you get additional performance boost from our beta JIT compiler, or you can compile them ahead of time into native executables. And I like showing this slide as an answer to this kind of tricky question that people sometimes ask me at conferences. So when should I not use GraalVM? And my answer is always use GraalVM, but decide for yourself which part works best for you. So if you want to stay in the JVM world, and maybe you are fighting for, squeezing out those last 5–10% performance improvements, you can probably get those with GraalVM as a JDK. Or if you want to go all in and get fast startup, low memory usage, etc., you can go with native image, but it's not either or. You really get to choose with GraalVM. And I also like showing this slide with our history because, A, I just think it's a beautiful slide, and I'm very proud of our team's design skills. But also, I'm proud of all the work that we have done over the time. So you can see we started working on GraalVM back in 2011, quite a long time ago. And then in 2019, we went with our first GA kind of production-grade builds. And it was a huge milestone for us after all the years, almost a decade of doing research. And then what I also like to point out here is that back in 2020, Alibaba already went with native image in production. So it might seem that this native image ahead of time compilation is this huge and scary and revolutionary technology, and it definitely is. I can see that. But also many people have been using it since 2020, so for like 4 years now, and they are very happy with the stability and performance that they get out of native image. And a few more things here. So you can see that some frameworks adopted GraalVM quite long ago, even before we had our production builds. But then in 2022, also Spring Boot went with GA support for native image. And it's really great because now you can also build Spring applications out of the box in a way that is compatible with GraalVM. So let's focus on native image. And if you have questions about other components, so JIT compiler, polyglot, you can ask me afterwards. But in this session, I want to focus specifically on native image. So how is it even possible to take something as dynamic as a Java application and compile it ahead of time? So the way this works is when you run our native image utility and you give it your application, and as an input, it takes bytecode, so it has to be class files or a jar. What it will do, it will look at your application, starting from its main entry point, and it will try to find all the reachable code. So all the code that your application is actually using and that is needed to perform whatever your application is supposed to perform. And then it will include only that code into this final produced native executable. And this applies to the code that you wrote yourself, so what we call user code, but also the code from all the dependencies and all your even JDK classes that you are using. So it will include everything that you need and strip down everything you're not actively using, this way minimizing the size of this native executable. And that is one part of the story, and that is why sometimes native image is called ahead-of-time compilation, but that is not the full story. There is one more thing that we are doing there, and that is we are looking at the objects that your application will allocate, and we will try to snapshot your heap so you can start faster with a pre-populated heap with the object that we consider safe to snapshot. So two parts of the story, we will look for the reachable code, and we will try to find objects that we can pre-allocate for you. And then we will put both of those things into this native executable that is also platform and architecture specific. So that is the idea. And two important things to keep in mind here and how it is different from running your applications on the JVM. So one thing that we are trying to do here is shift all of that work around executing your code from runtime to build time. So we offer you this trade-off where you can do all of that work, such as loading classes, analyzing, profiling, compiling, etc. Shift that work from runtime to build time. And that is because we think that most applications are run way more often than they are built. So it kind of makes sense to do all that work once as you are building your app, and then you can start much faster when you're running your application because you don't have to repeat the same operations every time as the JVM would do. That is one distinction, and another one is the way this is even possible to do so ahead of time is because we are doing this under a closed world assumption. So everything there is to know about your application needs to be known ahead of time because the runtime hasn't happened yet, and technically, with a few exceptions, there is no way of knowing what will happen at runtime. So we need to know everything there is to know about your app as we are building your app. Okay. Without all that's being said and done, let's look at the demo and see it in action. So let's start here with my native Spring Boot application. I hope you can see it. Let me just open that. So I have a number of things here, but let's start by saying that we have a plain Spring Boot application that has this one endpoint that returns our message. And let's see how we can run it on GraalVM. First of all, let me check my Java version. And you can see that I'm running here on GraalVM JDK 23. You might know that 23 is not even out yet, but you can already get our early access builds. So if you want to be on the bleeding edge and try the latest greatest, you can do so, and you can even help us test it. Also, if you're using SDK-man as you should, you can also install those early access builds from SDK-man. It's very easy. It's also what I did here. So, OK, this is our Java version, Oracle GraalVM for JDK 23. And I mentioned that it's a normal JDK, right? So we are trying not to be weird. So everything you can do on other JDK, you can also do on GraalVM. So let's run our application. And it runs, and it starts in somewhere around 1 second. And if we go here and update this, we see our message. So everything as we accepted, nothing too exciting yet. But where is the fun in that? Let's kill this, and let's recompile it. So let's do Maven, and I have a bunch of profiles for different purposes. For this one, I will just do pnative, so a plain native profile that Spring Boot gives you out of the box when you add GraalVM as a dependency. And now let's compile our app. And this is the stage where some people, especially if they are building a larger application, they would come to me and say, Alina, oh my God, this is taking so long. Why does it have to be that long? I don't have that kind of patience. Do something about those builds. Like, this is way too long. But as native image is going through our application, it will now analyze it, and it will show us what it has found in our app. And we will see just in a second how big our application actually is, even though on the surface it's maybe, 5 classes. So now the analysis stage is complete, and this is the part that I'm interested in. So on the left here, it shows us what is reachable, so what is actually being involved in what our application is doing. And on the right, this is the overall size of my app. And you can see that even this fairly trivial app, but granted, it does use Spring Boot, it has some dependencies such as Spring Web, it has some dependencies on the JDK. So even this trivial app contains, look at this, 17K reachable types, and types, those are classes, arrays, interfaces, etc. 26 almost K reachable fields, and almost 90K reachable methods. So Java projects, they are fairly big because they give us a lot of great features and batteries out of the box. But it also means that even a simpler application like this one, it has a lot of things in the project. So if, as a native image, you want to analyze the whole app and compile the whole app and understand what it's doing, it does take a while. But as I was chit-chatting in the meantime, our build was completed in 46 seconds, which I would argue is not too bad. So let's see what we got from the build. Let's do this, target. And here's my freshly compiled demo. The time is exactly as now, but the time difference is because it's a cloud instance in a different region. So let's go ahead and run this, target demo. And it starts. Only before it was 1 second, and now it's just 47 milliseconds. And if we go back here, it does do the exact same thing as on the JVM, but it has started, as you have seen, way faster. So I want to do one more quick thing here, which is not really even benchmarking, but let's say a minimal, quick, and dirty resources measurements. So let's do user bin time -v. And let's start the same app with the time command attached to it. And I will go back here and I will update my application a couple of times to send a few more requests. This is by no means proper load testing. We will do it later on. But let's say we have some app that is running and it's doing something. And as I was speaking, I have sent, let's say, maybe 35, 40 requests. So it does perform some work. It's not being just idle. So let's go back and let's kill it. And let's see what we see here. So we have a number of things here, but one thing that I want specifically to emphasize is the memory usage. And when we look at the RSS, maximum RSS here, we can say that it's around 73-ish megabytes. And this is the size, the amount of memory that my application has consumed as it actually has been working and serving those requests. Now, notice that I did not limit it in any way. So this was all the command that we have run. If I wanted to, I could have set my XMX settings to something minimal amount. I've tried, and even something like with like 12 megs of heap, it can still work and serve requests. But even having all the machine available to it, it can run and do our workload under such limited amount of memory. So this is pretty cool, I think. So this was a first plain demo that I have showed to you. And now let's see what are the benefits of native image and why would we be interested in building applications with GraalVM and with native image. So if you have heard one thing about GraalVM and native image and why you should be doing this, you might have heard that your applications would start fast. And this is something that we have seen in this demo where it started in 47 milliseconds versus 1 second on the JVM. And I guess you can agree with me that it's good for, let's say, cloud workloads, serverless, microservices. But what if you have a longer running application that you deploy, and then you run it for, I don't know, hours, days, weeks maybe, so you don't care about startup times that much? And I can agree with you that it's not all applications that care about startup time, but luckily this is not where the benefits of native image end. There are more reasons to use it. One is, as we also seen in the previous demo, is lower resources usage. So because we are shifting all of that infrastructure kind of work from runtime to build time, you can consume way fewer resources at runtime. And this applies to memory, to CPU usage, even to electricity. So if you want to maybe reduce your cloud bill or use less resources in your local data center, or even if you want to save the planet, the forest, the turtles, all of that, native image could be one good way to reduce the resources consumption of your applications. So that is one more benefit, and there is one more that I also actually like, and that is the predictable performance, and you will see it later on in the performance demo. And that means that our application, because it's pre-compiled, and there is not much to do for the runtime at runtime, it has a very predictable performance runtime from the very first milliseconds. And I also like how the Spring people call this feature, they call it instant performance. So from the very first milliseconds, your application can already serve requests, even under bigger load. and this performance profile is very stable over time, so you can be sure that you can meet your SLA requirements, and also you can be sure that your resources consumption is also very stable over time. Another interesting aspect, and I think people don't talk about this enough when they talk about native image because they often focus just on startup, is improved security. And that is that native image adds an additional security layer on top of what you can run on the JVM, because some attack vectors that target the JIT compiler specifically are just not possible in native image because there is no JIT compilation runtime anymore. And also, as we will see later on, more dynamic Java features such as reflection, serialization, etc., they are possible and they work with native image, but they require a bit more awareness and control and kind of an allow list from your side, so you have more awareness over what happens in your app and you can prevent certain things from happening in your app. You can also build much smaller applications. So if you want to maybe have just the size of your application smaller or being able to deploy and scale them easier with native image is definitely possible. And then if you're building a new application now in 2024 with all the support from frameworks and cloud vendors, there is really no reason for you not to use native image. So this is a quick overview of native image and all the benefits. And now I want to talk with you about libraries and frameworks and those what I call more dynamic Java features and what is the tricky part there. So if you remember this slide about compilation and how it happens under the hood, there is a certain challenge here for what we call more dynamic Java features, such as reflection, serialization, proxies, resources usage, etc. And that is because those things need to be allowed, specifically enabled by you as a user or by your library, framework, etc., to work with native image and native images closed world assumption. So for example, talking about reflection, how many of you have heard that GraalVM doesn't support reflection? Okay, still some people, still some work for us to do. GraalVM does support reflection, but there are things to know. So more more simple, more predictable reflection calls, such as class for name, class get method, native image can figure out and detect automatically out of the box by itself. It's not something that you have to do. But then if you want to do something a bit more tricky and less predictable and the runtime hasn't happened yet, you need to tell native image, hey, I want to be able to do this in terms of reflection at runtime. Please build an image that will allow me to do so. And to illustrate this and why I'm talking specifically about libraries and frameworks in the context of dynamic Java features, I want to illustrate this on the case of Spring Boot, because there are some frameworks that prefer to do things at build time rather than runtime, but Spring Boot, at least traditionally, prefer to do many things at runtime. So when you first run your application, what Spring Boot will do, it will look at your app, it will pull all the config from all the different places, and it will try to make sense of your application and build this kind of understanding of your app and what it's supposed to be doing by pulling all those pieces together. Now, this is all good, and what's interesting, native image is trying to do pretty much the same thing. So it will look at your application, pull all the config, and make the sense of your app, and also build what we call a universe of your app by pulling those pieces together. So it kind of looks like it's doing the same thing as Spring Boot, but it does so at build time. And there is a bit of a challenge here. How do you bridge that gap between Spring Boot and all the things that it wants to do at runtime and native image, and how native image wants to do those things at build time? And to resolve that kind of gap and challenge, there was this new project introduced in the Spring ecosystem called Spring AOT. And that is a new kind of module and engine in the Spring Boot framework, which plugs into your build process when you build your native image application and transforms it in a way that it's more friendly towards native image automatically. And the way it works precisely is that it will look at your application, analyze it, and then it will produce certain things for you. So one such thing will be Java source files. For example, it will transform some of your configuration into more kind of functional style configuration that is easier for native image to understand. That is one kind of type of artifact it will produce. The next one is bytecode, and that is for things like proxies. And the last item it will produce is so-called hint files. So the hint files are configuration files for native image that enable those dynamic features such as reflection and serialization. So this is what a framework can make for you to make your application more easily understandable by native image. And with that being said and done, let's see one more demo, a couple more demos of Spring and GraalVM in action. So let me go back here, and let's see how we can build something maybe a bit more advanced with Spring Boot. So the next thing I want to show will be a Spring AI, where is it? Spring AI demo, because obviously you cannot come to a conference these days and not show an AI demo. This is just not acceptable. So this is the application that we will be looking at. And this is using a Spring AI, so this slightly recently introduced new AI module in Spring Boot. And what we have here is a travel recommendation app. Come here, where we are taking an input from a user about where they want to travel and what is the kind of activity that they want to do and what is the mood that they are in. And then we will use that input to go and talk to the OpenAI API and get travel recommendations for them. And not only this is using newly released Spring AI, but this is also using the latest and greatest GPT-4o. And while I remember, I also wanted to show you the size of the application. So to save us time, I already have it compiled. And if you look here, my whole application with all the classes, resources, etc., contains just 109 megabytes. If I care about the image size, I can take it down even smaller with things like UPX. But honestly, for me, this is good enough. I don't need to compress it any further. So let's go ahead and run this. Target travel app. And it started at the port 8080, so let's go there, and let's remove this. OK, let me zoom out. Can we stop here for a second and appreciate this beautiful UI that I have built? I know that it doesn't look like a lot, but trust me, thank you. Trust me, this is much better than it looked in the first iteration of this app. So let's say we want to travel to Switzerland. Let's say we want to do hiking. I don't really want to, but you're going to have to if you're traveling to Switzerland, I'm afraid. And let's say we are feeling adventurous. And now let's wait for the OpenAI API call, and let's see what it gives us. OK, this is a new one. I'm not even sure I can read it. Interlaken, I don't know, but says volley of 72 waterfalls, so it does sound good. Let's give it a try. But also just to make sure that this is still working and it doesn't, it's not any pre-baked data. Let's say we want to go to Poland instead. And maybe, I don't know, let's say we still want to do hiking. So let's see if we can get travel recommendations for hiking in Poland. OK, and this says that you should be visiting the Tatra Mountains. I haven't been there, but I have heard very great things about them. So I think this is a good recommendation. So this is how we can build such an app with GraalVM and Spring Boot. And I want to emphasize here that I haven't done any config. All of this just works. I just pulled in as my dependencies Spring Web and native image and Spring AI, and all of it just worked. And maybe I have the time to show one more slightly related demo. Let's do this sentiment analysis one, and let's start it, and I will show you what it does. I think we are there. Sentiment analysis, I think. OK, so this is a very similar app, but let's say we want to have a different business use case. Well, let's say we are working at a bank or, I don't know, hotel chain, and we are getting some reviews from customers, and we want to be able to evaluate the sentiment of those reviews, but they don't come in all the time. They come in once in a while. So maybe we want to have something like this deployed as a serverless somewhere and only trigger this app to get on when we actually have a new review. So let's start with this, and let me remove all of this, and let's see if we can get our app to analyze a sentiment. And let's say GraalVM is the best VM in the world. And I need my emojis. Where is it? Here. OK, evaluate. And now we should get a feedback that this is very positive because of the language, but also because of the emoji. And now if we try something else, I don't know, GraalVM is a reasonable VM. And let's do this. Evaluate. So this should be maybe more neutral or slightly positive. Let's see. Neutral with a hint of uncertainty. Okay, this is very detailed, but this is what GPT-4o will do for you. So this is how you can build such applications with GraalVM and all the latest and coolest libraries and frameworks. And speaking of that, I want to talk with you about how you can use different libraries in your GraalVM applications. And here I will show this slightly scary slide, but this is important, so I want to show it and talk to you about it. So I have mentioned already how things like reflection, serialization, proxies, resources require a bit more work from your end. And this is also the reason why some libraries work with GraalVM native image more easily, and some require a bit more work to be available in the native image mode. And this slide is an overview of all the possible scenarios. So each bullet point is a valid option of how a library or more dynamic Java feature can work with GraalVM. And this is going from the best case scenario to a scenario where it requires a bit more work from you as a developer. So in the best case scenario, we see this a lot lately, where new libraries, as they appear in the Java ecosystem, they're being developed and designed from the ground up in a way that is friendly towards GraalVM and native image. And this is very cool. So if we open this tweet, we saw this new library coming up, and the author said that it's native image compatible out of the box. So this is the best case scenario where it will just work, no work needed from you as a user. But obviously, there have been around many libraries before native image even appeared to be. So what if you want to use some library that existed before native image appeared and that was designed not with GraalVM in mind? So then the best possible scenario is when the library will include this necessary config for GraalVM and things like reflection within the library itself. So as the example here, we have H2, and I used to show in the past a demo where I would try to write data to H2, and my application will blow up at runtime because it could not understand how to work with H2 without config. But now I don't even need to show the demo anymore, because if we go back here to the H2 actual source code, you can see this is on GitHub, all open source. There is this reflect config file, and this tells native image, hey, please build an application with all those things in mind and make them work with reflection as a native image. And having this in mind, native image can include all those calls, and again, your application will just work. So this is the next possible optimistic scenario, but also we understand that not all the libraries have added support for GraalVM yet. So what to do if your library is still working on GraalVM support, or maybe they are not ready to add it yet? And it seems like maybe, for example, let's say H2 again, let's use it as an example. Let's say I already worked as a user with H2, and I have those config files that make H2 work with GraalVM. So it seems like there should be a way to share those config files between the users and have something maybe kind of like Maven Central, where you don't need to discover config for all the libraries by yourself, but as users or maintainers, you can just share those things in one centralized place, and then you can pull them automatically from that place. We thought so as well, and for that we have created this reachability repo. We are looking at native here as an example, but overall it's a big repo that we have created together with our partners in the ecosystem, where different library authors and users can contribute config for all those things, and this makes them work with GraalVM native image out of the box. You can just pull this config from the centralized repo. And the best thing is that this is integrated with our Maven and Gradle plugins. So if you have added our Maven and Gradle plugins, or for example, if you are using Spring Boot, which adds our Maven and Gradle plugins under the hood for you, this config will be pulled automatically. So let's say if you want to do, I don't know, Postgres or test containers, and you're using Spring Boot with GraalVM, this config will be pulled from here automatically for you. So again, those things will work. And those 3 bullet points, I would say this is happy path, but also most of the cases if you will be starting to build a new application now in 2024. But let's say things are not so well, and you want to, you see that your application is not working, so you need to make those dynamic features work manually, more or less. What you can do. So the next bullet point here, this one, is that if you are on a framework and framework version that is compatible with GraalVM and native image already, usually those frameworks offer some kind of programmatic way to create those hint files for native image. If we go back to our first Spring Boot example and look at extra things there, I have 2 more controllers there that are trying to use reflection and resources in a way that is not so obvious to the native image. Here, for example, we are doing reflection, but in a slightly more confusing way to try and outsmart native image. And to make this reflection call possible, they can call this runtime hint registrar API from Spring Boot and say, hey, I will want to access this message field from this message class programmatically at runtime. Can you please generate hints and make this work with GraalVM? And then this will work. And the same thing applies to my resources. So let's say at runtime, I want to load this resource and read it at runtime. I can once again call this API from Spring Boot and say, hey, I want to be able to access this message XML file at runtime. Can you please generate hints to make this possible when my application actually runs? So if you are on a framework that is working with GraalVM already, this is the next thing that you can do. You can programmatically generate those hints. Now, let's say that things are even not so good anymore, and you are also maybe on an older version of a framework, or maybe you have some internal framework, and there is no support whatsoever for GraalVM. So what you can do then to use the dynamic Java features, there is one more great thing that is automatic or semi-automatic, and that is that we have this tracing agent in native image. And the way this works is that you will run your application on the JVM with the agent attached to it. And what it will do, it will detect all the calls that you are making at runtime in terms of reflection, serialization, and resources. And it will produce config for all those files for native image. And it will even put this config in a location that native image knows and can automatically pick up. The only thing to keep in mind here is as you're running your application on the JVM with the agent, you need to more or less accurately emulate the runtime behavior of your app. So let's say I wanted to read this resource and make it available in native image. I also need to run my application on the JVM with the agent and read the same resource at runtime to execute this code path and to make this call visible to native image that, hey, this is what I will be doing at runtime, and then we can generate this config for you. And the last step here that is the most work, and hopefully this is not something you will ever have to do, but for the sake of giving you all information, I need to mention this. You can also produce those files manually. The format the native image works with is JSON files, where you can say, hey, please register this resource and make it available at runtime. But hopefully this is not something that you will ever have to go to. So ideally, if you are starting a new app, you will be somewhere within the first 3 bullet points. And if you want to migrate an existing application, the next 3 bullet points is something that can help you there. So hopefully this was the scariest slide for this whole presentation. Now we can move on, but I think it was important to know if you want to use libraries with GraalVM. And if you want to quickly assess if you can move your existing project to GraalVM native image, we have this page on the website where you can find a list of known libraries that are compatible with GraalVM and native image. Notice that this is not a complete list. There are more things out there, but this is what is contributed by the community and is known to be working and testing continuously with GraalVM. At the moment, it's something like maybe 200 libraries, and obviously we welcome new contributions. Okay, and now let's talk about performance. I work in a compiler team, so obviously I care about performance a lot. And let's talk about AOT versus JIT. Let me ask you, who here believes that AOT compiled code can be on par or faster than the JVM? Okay, some people, but not too many. So, let's make an experiment and let's see if we can make it work this way. For that, let me clear all of this and let me move to a different demo. So let's talk about performance, and here is my app, and we will be doing benchmarking here, and we will be doing benchmarking on the case of the Spring Pet Cleaning application. I think you all know that one, but just for the sake of showing what exactly we will be demoing, let me do this. So let me run Spring Pet Clinic, target, and just a plain Spring Pet Clinic app. And it starts, and it's on 8080 again. And notice that this is a larger application, because even on the native image mode, it starts in 200 milliseconds. And then the JVM version of this app starts in something like 5 seconds. So it is indeed a larger application. And then if we go here, localhost, we see our UI. OK, I think it's zoomed out. Yeah, that's more like it. And this is a good representation of your normal kind of enterprise web app, where you can read data from a database, write data. You can, for example, find owners, add a new owner. Let's add something. Let's maybe also not leak my personal address. Let's do something else. Let's do this, blah, blah, blah. So we have an owner. We can now add a pet, add a visit, etc. So more or less a normal web app. And we will be benchmarking this on the JVM versus GraalVM. And let me show you the benchmarking setup, because I'm quite proud of it. So what we will do here, let me move this down. So first, we will benchmark this on the JVM, and we will be using the C2 JIT. This will be effectively your OpenJDK kind of setup. And what we will do here, we will start our pet cleaning application. Then you will wait 10 seconds for the application just to start, because we measured this and it seems like usually it starts in 5 seconds, but just to be on the safe side, we will wait 10 seconds here. Then we will do a warming up run, because we want to do more or less scientific benchmarking and warm up before we actually measure something. And then we will do the actual measurements run for 20 seconds. And this is the setup, and the actual workload that we will be running is defined here in this Lua script, where instead of starting the app and just bombing the main page with, let's say, 1 million requests, we will try to emulate a normal user behavior. We will be creating new owners, creating new paths, then reading data. So this is maybe not the most scientific benchmark in the world, but this is fairly scientific for like 5-minute section at a conference session. So I'm very proud of this benchmarking setup. So let's go ahead and benchmark this on the JVM. And bench JIT, I think we want to do C2, right? Yep. So this will now start our application. And first, we will wait 10 seconds for the JVM to start to make sure it's all ready to even receive our warming up load. And now the startup run is completed. We are warming up our app by sending the actual load, but we are not considering this representative numbers yet. It's just warming up. And as it is warming up, we see some results already from the worker that we are using as our load testing tool. And the peak throughput that we have in the warming up round is 465 requests per second. But we know that the JVM warms up, so we can expect that it will be better over time as it is warmed up. OK, now it is completed, and we see that the final peak throughput was 100.4 requests per second. Let me remove this, and let me get one more tab, and let me also run this on native image. So bench native, I think just this. Let's do this. And as it runs, I will have more time to tell you what it's actually doing. So this is my native script. And that's pretty much the same thing. So it also starts and waits 10 seconds. It doesn't need 10 seconds, but we want to have the apples-to-apples comparison with the JVM. So we are waiting the exact same time. And then we are doing warming up run, and then we are doing the actual benchmarking run. So who thinks this will be faster than the JVM? Some people, but I work on GraalVM, so I could have done something to the binary to make it faster than the JVM. I don't think you're giving me enough credit. Let's see. OK, it is warming up. And now it is finished. And what we see here, oh no, it is slower than the JVM. Now, it is somewhat slower, but I want to emphasize here that the JVM is a great piece of engineering, and it's very hard to beat it at its own game. So I would say this is still on par. But our users always challenge us to do more and better. So let's see if we can do more and better. And I can do one more run where I have built the same native image, but with extra optimizations on top. So let's see if this will be any faster. OK, so it will now wait again for 10 seconds, then do 10 seconds of warming up and 20 seconds of actual benchmarking run. And just to recap the numbers, the JVM had 1.4 requests per second. Our plain native image out of the box was at 1.1, so slightly slower. And the actual benchmarking numbers are still coming up for the optimized run, but you can already see that even warming up run is faster. It's at 1.7, even slightly faster than honestly I have expected. But let's see for it to be completed and what will be the numbers that we will get in the end. And we do see that it is even slightly faster than the JVM in the exact same run. Now, I will not make a big promise here that every single application that you will take will compile and run faster on native image than on the JVM. All applications are different, are doing different things, have different dependencies and profiles. But it is possible if you apply all the necessary optimizations to run on par with the JVM, and we are working to make native image even faster. So this was peak throughput, but a part of our benchmark was that we were also measuring resources consumption of our app. Let me just close all of this, and we will be able to check out how many resources our applications in all the different modes consumed as we were running our benchmark. So we have generated those charts over here using PS record, and let's compare them. So this was the JVM, this is native image, and this is native image optimized. And I'm showing this to once again make a point about the resources usage. So the way to read this is the blue horizontal line, that is our memory usage, and the application was set up in the same way in all the modes, so it technically should have used the same amount of memory. So the blue one is memory usage, and the horizontal, the vertical red spikes, that is CPU usage. And this is JIT, this is native image plane, and this is native image with all the batteries and optimizations. And I have a few conclusions here. Obviously, you can see that the JVM version uses more resources in terms of both CPU and memory than native image in both modes. And here is the startup that I have mentioned before, so 5 seconds for it to start, and then we are waiting for 10 seconds, while native image just has nothing to do because it doesn't need to warm up. Technically, it was ready to serve requests from the very beginning. And one observation is that native image consistently uses less memory. So here we also peaked at something like 700 megabytes, while native image used 200, and then closer to, let's say, 500 in the final round. So the big difference in memory usage here is that this final round, fully optimized, is using G1GC, and G1GC tends to use a bit more memory, but also gives us, as you have seen, much better throughput. And in general, I think that is a sentiment that we all share, that in general, you can trade off memory for throughput, because you always need to give something if you want to have something in return. And here, by giving or using more memory, you also get more throughput. And with that being said, let me show you the specific optimizations that I have used to make this application as fast. So how you can make it as fast on native image as on the JVM. So one, and probably the most important performance optimization that you can do, is called profile-guided optimizations. And this is very interesting because you might know that the JVM is so good at peak throughput because as your application runs, it also observes your application behavior, collects profiles, and it is able to adapt on the go to what is happening in your app and de-optimize or compile again, looking at what your application actually does and where it makes sense to invest compilation efforts. And technically, for native image, this is not possible because runtime hasn't happened yet, and also we don't include all that code execution infrastructure at runtime that is needed for JIT compilation. But with PGO, what you can do is you can build an instrumented version of your application, run it, collect profiles, so do kind of the same as the JVM does, and then use those profiles to build an application that is aware of what will happen at runtime, and that can also invest compilation efforts where it makes the most sense to invest them. And this way, you can combine the power of ahead-of-time optimizations that native image usually has with the runtime awareness of what the JVM normally has. But it requires 2 steps. So you need to build an instrumented binary, you need to recompile them, and it's not always that it's possible. And also, honestly, it's not always that you care that much about peak throughput. So what to do if there are no profiles at all? And it seems like predicting what your application will do at runtime and predicting its possible profile is a good task for a machine learning model. And indeed, that is the case. A native image contains an ML model that will look in your app, and if there is no profiles at all, it will try to predict what your application is supposed to be doing. And this is not as good as this first kind of user-provided custom profiles, but this will give you maybe 6-8% performance improvement over not having any profiles at all. This is pretty cool. And I did mention G1GC. There could be different GC strategies, but our observation is that for native image, the best option if you want to have good peak throughput is to be using G1GC. And the last smaller one, but if I know that I will be, let's say, running my application on the exact same machine that I'm using, so I will not be sending it to any users or anything like that, so it will always run on the same machine, I can use this mArch native flag, and this will leverage the specific hardware features of my machine and tailor the app to specifically my machine to get the best throughput out of it in terms of using the hardware. So if you want to have very fast native images, this is your recipe for making it happen. And I think I will skip the other performance metrics because I want to show you 2 more cool demos. And I want to mention some practices for working with native image and building applications. So I did mention that native image builds applications that are platform and operating system specific. It's not possible to build, let's say, on my Mac machine for a Linux machine because we need some JDK specific classes for each platform. But there are many solutions to it. One solution that I like is using CI/CD systems. And in particular, I like GitHub Actions. And honestly, I talk about them a lot. I feel like Microsoft should start paying me at some point or something. But GitHub Actions is a good way to build binaries for all the platforms. You just set it up for your repos. You say that, hey, I want to build for Linux or macOS, and you can build there. And it's a good way to build kind of cross-platform specific applications. Now, if you want to move your application to GraalVM native image, here are a few things that I can recommend to you. The number one step always will be to add our Maven and Gradle plugins that we call native build tools, and that will help you build applications, integrate libraries, test, etc. That is always a good first step. And then, in general, we recommend that you keep building and testing your application on the JVM, and then you compile to native image as more or less the last step in your deployment process, or maybe in your CI/CD, or let's say once a day, or when you introduce a new dependency. But you don't have to recompile all the time, especially if you're mostly introducing changes to your business logic and not touching any low-level things. And for performance optimizations, all the things that I have mentioned above will give you good peak throughput. Now, what's next? And some time ago, we had our JDK 22 release. And for that, I want to show 2 final demos. I think I still have time for that. So I want to show you the things that we have built for that last release. Let me just close all of this. And let me close some of those. And one thing that I want to show is LangChain4j. Maybe you have been in the LangChain4j sessions because there are quite a few of them at this conference as well. But I want to show you a native version of one of them. So let's do this. And just to show you the size of my app, this is already natively compiled Java application that is using LangChain4j. And if you look at the size, where is it? Oh, but we need target, right? Yeah, this is my binary. So 47 megabytes is my complete compiled application. And then if we run it, target native LangChain4j, and we need to tell it something. So this is just a plain Java app that will go and make a call again to the OpenAI API, but using LangChain4j rather than Spring AI in this case. So let's do hello. And let's maybe ask it, what is GraalVM? And this is also using ChatGPT 4o, so I think this might be a while, but let's see. Come on. OK, it gave us a very long output that is high performance, multi-language support, etc. And let's ask it one final thing. Is GraalVM, let's do something controversial, a good VM? So you know this will be dynamically generated, so it totally can say something bad about GraalVM. Let's see. OK, it gave us a very long output. I don't know why, but it says it's a strong candidate for many modern application needs. So I would say overall it's a positive feedback. And one more final demo that I want to show is this native modern Java. So this is a demo that I have adopted from my colleague Nikolai Parlog. Anyone here know Nikolai? Yeah, we all know and love Nikolai, right? So he has this modern Java demo where he showcases all the latest Java features such as virtual threads, web client, pattern matching, etc. And I have a little fork of it that is called native modern Java. Where is it? Native modern Java, this one. And the only change pretty much that I have introduced in Nikolai's app is I have added our Maven plugin, this one. That's why I'm always saying start by adding our plugins. And I just integrated the plugin from our docs, and I specified the name, and I enabled preview features because Nikolai is using preview features of Java 22. So let me quickly go ahead and run this. And the app itself is a GitHub crawler. So I need to give it a URL that we want to crawl, and it will crawl that URL and give us the output of what it found on that page. So let's do this. And we need to specify our preferred crawl depth. So let's say it's 3. And it did crawl the page, but also it has produced this beautiful page for us. But you can also appreciate Nikolai's front-end skills as well. And this is all running as a GraalVM native image application using all the latest Java features. So if you are wondering if you can use the latest Java features with GraalVM, obviously you can. Now with that, I think I only have 1 minute left. So let me show you the final slide. If you want to have, if you have any question, I will be here down the stage afterwards. But also you can ping me on Twitter if you would rather ask something online. And if you want to get the demos that I have showed here today, you can scan this QR code, and that is all of the repos that I have showed in this session today. And with that, I want to ask you, please rate this session. And it was a pleasure talking to you. Thank you so much for your attention. Thank you.